Chapter 4, Section 4. We're now going to look at our economic application in this chapter of what we've been doing. So just to review, revenue is going to be the money you get from selling a product. Cost is your expenses to make that product. And your profit will be your revenue minus cost. So how much money you take in minus how much money you spent. Marginal revenue, we said, was the derivative of revenue. Marginal cost is the derivative of cost. And marginal profit is the derivative of profit, which is marginal revenue minus marginal cost. The main thing we want to look for is how to maximize profit. This is usually going to be the goal for any business, so it's a very handy thing to know. There's two ways we can do this. We can look at a graph, or we can do this with formulas. If you look at a graph, what we need to remember is that you have a profit if revenue is greater than cost. So the amount of money you take in is greater than the amount of money you put out. So we're going to have a profit whenever revenue is greater than cost. So looking at our graph, you can see that that happens about between, I would say, 70 and 190. So you can see there that the revenue graph is above the cost graph. But how do we know where profit is maximized? Well, profit's going to be maximized when revenue and cost are the greatest distance apart, because that means that you're taking in much more than you're putting out. So when you have a graph, the first thing you want to do is find the area where revenue is greater than cost, and then find the spot in there where the revenue and cost are furthest apart. That is going to be the place where your profit is maximized. So here on this graph, it happens right about Q equals 140. So if you have 140 items, that's where the profit will be maximized. And to figure out what the maximum profit is, you want to draw in the point on the revenue graph and on the cost graph and find the corresponding y values. The difference between the y values will give you the actual maximum profit. So that's what you'll be looking for graphically. If you're given formulas, it's a little bit different. So let's suppose that we want to maximize profit based on some functions that were given for revenue and cost. Maximizing profits just like maximizing any other function. We want to find the first derivative, set it equal to 0 to find our critical points, and then go ahead and make sure it's a maximum. So here, revenue is given as 500q, and cost is given as 100q plus q squared. So to find the maximum profit, we first need to set up our profit function. So remember, profit is revenue minus cost. So here, revenue is 500q minus cost, which is 100q plus q squared. Remember to subtract off the entire cost function, not just the first term. Combining like terms, we get 400q minus q squared. Once you have your profit function set up, we want to find critical points of this profit function, so we find the first derivative and set it equal to 0. The derivative of 400q is 400, and the derivative of q squared is 2q. So our derivative for our profit function is 400 minus 2q. We set that equal to 0, and we solve for q, giving us q equals 200. That's going to be our critical point for this function. We now want to make sure that this quantity that's our critical point is actually a maximum. So we look at the second derivative. Using the second derivative test, we look at the second derivative is going to be negative 2. So any number you plug in for q will give you negative 2. If the second derivative is negative, that means it's concave down and is indeed a maximum. Of course, you could always graph the profit function as well to make sure you have that maximum. So q equals 200 is the quantity that maximizes profit. If you want to know what the maximum profit is, you would plug q back into the original function. On a side note, notice that we said before that the derivative of profit is going to be marginal revenue minus marginal cost. To find a critical point, we set that equal to 0. So we could say that profit will be maximized when marginal revenue equals marginal cost. Another thing we want to look at is something when we use demand equations. Sometimes if you want to maximize revenue, you'll be starting with a demand equation. So if they give you a demand equation such as this, q equals negative 3p plus 48, and we want to find the quantity and price that maximizes revenue, the first thing we have to do is set up our revenue function. Remember that revenue is price times quantity. Well, here, the demand equation gives us an equation for quantity. So instead of q,